Welcome back, students. In last video we obtained electric field due to linear charge distribution, a thin long wire on its axis. This time we will try to find out electric field due to same wire. Suppose we have one rod which is uniformly charged, but this time we won't find out on axis of wire, we will find out on perpendicular to the axis. So suppose we are taking point P which is at distance r from wire. Wire is of finite length L and it is uniformly charged. Linear charge density will consider lambda. We want to find out electric field at point P. Now angle subtended from point P to one end is θ1 and at another end it is θ2. So again this is continuous charge distribution. So we'll have to start with a small segment. So what we'll do, we'll take a small segment over here. This much segment having thickness dx at distance x from this perpendicular point from P. Now electric field due to this segment here P point, it will be in this direction. Electric field will be like this. This electric field will considered dE electric field. If we take this particular angle as theta, then electric field will be divided into two perpendicular components. This angle is theta, so this angle will become theta, and here one component of electric field which is perpendicular to this wire is dE cos theta, and another component which is parallel to the wire is dE sin theta. तो सबसे पहले हमने यहाँ पर electric field will try to find out due to a small segment and will split it into two components. One is perpendicular to the wire and another parallel to the wire. Now we'll try to find out value of or magnitude of this dE component. So if we write this particular length from point P to point O, we have taken r. Here this length is x, so this will be root of x square plus r square. So we'll start with small segment. Electric field produced by charge dq present over here, dE is equal to k into dq upon r square. R is distance from this point to this point, which is equal to x square plus r square. Now in terms of linear charge density, here lambda is equal to dq divided by dx. So dE will become k into lambda into dx upon x square plus r square. So here we'll have equation in terms of dx. Now when we apply limit in theta, we need to convert this dx into d theta form. So here relation between x and r is, now x upon r is equal to tan theta. In this particular triangle, opposite side upon adjacent side we take, then it will become tan theta. So x is equal to r tan theta. Now we want dx value, so if we differentiate this, then dx is equal to r constant, differentiation of tan theta is sec square theta into d theta. So if we substitute this value in our first equation, then dE is equal to k into lambda into dx. Dx is what? R sec square theta into d theta upon x square plus r square. So x is r tan theta. So this will be r square tan square theta plus r square. So here k lambda r into sec square theta d theta upon, we can take r square common, that will be tan square theta plus 1, which is again sec square theta. So here sec square theta cancel, 1 r get cancel. So dE is equal to k lambda into d theta upon r. So now we have value of dE. So if we want to find out electric field's component which is perpendicular to this wire, then that will become dE cos theta. So what we can do is, now first we'll find out perpendicular component of electric field. So perpendicular component. Now perpendicular component E perpendicular is equal to, here integration of d cos theta. So integration of dE cos theta. So that is integration of, what is dE? K into lambda upon r. K into lambda upon r into d theta. So into cos theta into d theta. Now limit will start from theta 2, which is negative, to theta 1. So if we integrate this term, then here k lambda and r are constant. So E perpendicular is equal to k lambda upon r constant, integration of cos theta into d theta. Integration of cos theta is sin theta. Lower limit is minus theta 2, upper limit is theta 1. So now this is k lambda upon r sin theta 1 minus sin minus theta 2. So this will be equal to k lambda upon r in bracket sin theta 1, sin minus theta 2 is equal to minus sin theta 2. So minus minus will be plus. So plus sin theta 2. So this is equation of perpendicular component of electric field. Now if this wire is of infinite length, if we consider that this wire is extended up to infinite length, then this theta 1 will continuously increase. As the length of wire increases, the theta will go on increasing. So what is maximum possible value of theta? That we can take 90 degree. So if wire is infinite long, if wire is infinite long, then theta 1 will be equal to theta 2 will be equal to 90 degree. So here we can take 90 degree. So in this particular condition, E perpendicular will become k lambda upon r into sin 90 degree plus sin 90 degree. This is 1 plus 1, 2. K is what? That is 1 upon 4 pi epsilon 0 into lambda upon r into, this will become 2. So here lambda upon 2 pi epsilon 0 r, this is electric field produced by wire which is of infinite length in perpendicular direction. Now we want to obtain electric field's component which is parallel to wire. That means which is sine component. So next we will calculate parallel component. Parallel component. So parallel component is here dE sin theta. So when we will find out parallel component, then we will have to integrate from minus theta 2 to plus theta 1. This is value of dE, which is k into lambda upon r. Now here the component is sine theta. So this time we have to integrate the function which is sine. So now E parallel is equal to k lambda upon r constant, k lambda upon r constant, integration minus theta 2 to theta 1 sine theta into d theta. So that is equal to k lambda upon r. Integration of sine theta is minus cos theta, minus theta 2 to theta 1. So if we take out this negative sign, minus k lambda upon r, upper limit is cos theta 1 minus lower limit is cos minus theta 2. So this is our equation. If we further simplify it, then E parallel is equal to minus k lambda upon r in bracket cos theta 1 minus cos theta 2, because cos minus theta is equal to cos theta, so minus will remain as it is. So this is formula of perpendicular component, parallel component of electric field. Now this negative sign indicates that electric field produced is in downward direction. Okay, so perpendicular component is k lambda upon r. If we write formula of perpendicular component again, then electric field's perpendicular component was k lambda upon r sine theta 1 plus sine theta 2 in this direction, while parallel component, which is electric field's component in this direction, that is E parallel is equal to minus k lambda upon r cos theta 1 minus cos theta 2. For infinite wire, electric field's perpendicular component becomes lambda upon 2 pi epsilon 0 r. If we take infinite long wire here, for infinite long wire, theta 1 and theta 2 will be nearly equal to 90 degree. So if we put up 90 degree over here, then E parallel is equal to minus k lambda upon r cos 90 minus cos 90. Cos 90 is 0 degree. 0 minus 0, that is 0. So this whole term will be 0. So this particular segment indicates that when wire is infinite long, it has no parallel component of electric field. Its electric field is always in the perpendicular direction and it is equal to lambda upon 2 pi epsilon 0 r. That means if we have a long wire which is uniformly charged, this is infinite long wire on both sides, and we want to find out electric field due to it at distance r, point P. So this electric field is always perpendicular to the wire. Direction of electric field is always perpendicular to the wire, and magnitude of this electric field is lambda upon 2 pi epsilon 0 r. E is always lambda upon 2 pi epsilon 0 r. So here electric field varies inversely with distance r. So if we double the distance, electric field will become 1 by 2. In point charge, relation was E is inversely proportional to r square, while in linear charge distribution, relation is E is proportional to 1 upon r. So if we draw graph of electric field versus distance for infinite long wire, then the graph will be like this, and nature will become hyperbola. So this particular segment is special case of wire. So this is infinite long wire.